Welcome to Study Loop.
In this question, we have this situation. So we have a hoop. Okay, there is nail at this spot. Okay, and then it's being displaced by an angle beta. Okay, so this is the angle beta, and then this is like where the center of mass is, uh, and then this is like where the center of mass of the hoop when it's at equilibrium position. Okay, and so this is the before. Okay, and then after that, or the final instance that we are considering in this case is to find the angular velocity when it's back to equilibrium position. Okay, yeah. So yeah, in this question we have a hoop that is being displaced by angle beta from the vertical line. It is nil at the rim over here, and then it's being released from rest, and then it's going to rotate about the where the nail is, and then at at the equilibrium position it's going to have a angular velocity. Okay, so to solve this problem, first we need to recognize a few things. We'll be using conservation of energy, and then you also realize that the hoop is not rotating about its center of mass. So we are going to use the parallel axis theorem. Okay, so using parallel axis theorem. Okay, so the I of the hoop in this situation is this is ICM mr square, and then plus mr square as well. Okay, because it is shifted by a distance r. Okay, so this is equal to 2mr square. Okay, and then we'll be using conservation of energy. Okay, and the system that we are considering, okay, the system is the hoop plus the earth. Okay, so we have ki plus ui equals to kf plus uf. Okay, so ki is 0, and then ui is mgr, okay, 1 minus cosine beta. Okay, how do I know that? So okay, this is r, this is also r. Okay, and then this is beta, the angle beta, and so this change in height, okay, this h here is going to be r 1 minus cosine beta. Okay, so cosine beta refers to this length. R cosine beta is this length. Okay, this is r cosine beta, and so this part, the bottom part, is the you need to subtract r cosine beta from r, so you get r times 1 minus cosine beta. Okay, and then kf is half I omega square, and uf is 0. Okay, okay, so mgr or big M, okay, better to use big M, times 1 minus cosine beta is equal to half times 2mr square omega square. Okay, the 2 cancels out, the m cancels out, one of the r cancels out. Okay, so you have omega square equals to g over r 1 minus cosine beta, and so omega is g times 1 minus cosine beta divided by r, and then you take the square root. Okay, so this is the answer for this question, and that's all.